Every great project requires a really tight collaboration between the subcontractors, the builder, the architect, and the structural engineer. And this project is a passive house. And passive house requires even tighter collaboration because you have to worry about a lot of things, not only structural integrity, earthquake safety, long-term durability, but you have to worry about things like thermal bridging. Thermal bridging is when a highly conductive material goes from inside a house to outside a house. And this corner right here is this example of where the architect and the structural engineer and our team really got together and put our heads together. And we see in this corner that we have this small steel beam. Now, this whole corner of this building is entirely giant doors. And we have this one small steel post right here that goes up to a giant wood beam, a wood parallam. And that wood parallam goes from way in that corner all the way out here. So we have these two big doors right here that have this amazing view, and we have no structure except for this one tiny little post. And if you look right here, the tiny little post is inboard of the exterior walls of where the doors are. Now, why is that important? Well, if this was a bigger steel post and it was out just 4 inches, it would involve this amazing thermal bridge from outside the house to inside the house. And this corner would be cold, it would be prone to condensation. There would be a lot of problems. Now, any good outside deck, because that's where we're standing right now, is an outside deck. And yet this 7 inches away is the inside of the house. Now, you see this giant step right here. This step will be taken up by a lot of insulation, sloping this deck underneath the finished material to drains that then drain the water away from the structure. This deck has a bunch of steel underneath it, but you can't see any of it. Now, why is that? Well, let's go into the garage and I'll find out. And here we are in the garage. This is down below that conditioned space. Over here is the deck, and here is the floor framing on the inside of the house. And what we've done here is we've dropped the steel down so that the steel is entirely outside the insulated envelope. The floor system is up here, and yet the steel is down below. That means that this highly conductive steel won't allow energy to transfer from the outside of the house to the inside of the house. We have a really low ceiling in this garage, and we can't add a bunch of insulation below here. The only way to do that was to put insulation in the floor system and above the steel. So now the steel is outside, because here is the other problem. The steel is on the outside in the deck. The deck is not going to have a ton of insulation in it. So we can't structurally connect these without having the steel go inside to outside. So the steel is entirely on the outside of the thermal envelope. And that means that the insulation is inboard. So why do we have to have steel here at all? Well, I'm standing under the exterior of the house right now. This is going to be a deck. And this deck goes out about 18 feet from the house. And the only support for this entire portion of the house is that post right there and that post right there. That post over there and that post over there are temporary, which means this entire roof is cantilevered based on just these two posts right here. And when you have large spans and very little support, it often requires steel, especially in earthquake country. So that steel goes from outside the house at the decks all the way in through this big steel beam right here to inside the envelope of the house. Now, it's inside the exterior membrane of the house. This is actually the garage right here, but it's not inside the thermal envelope, meaning where the insulation is. So what we've done by dropping this steel down is we've kept the steel, which has to be on the outside of the house, from going inside the house. The thermal conductivity of steel is about 500 times more than wood. So if we can just keep wood on the inside and steel on the outside, we have no thermal bridges. And no thermal bridges means no condensation, no rot, no cold spots in your house, and a nice, comfortable, warm house that will last forever, will never have problems, but most importantly, will be super, super comfortable. If you're interested in learning more about building science, hit subscribe as we show you how to build a better way.